Hello everyone, welcome to another devlog. So today we're going to go over how this old renderer kind of works, and then we're going to be restructuring the project a little bit and then talking about this new renderer and where we want to take where I'm basically going to settle on for the renderer, I think. So with the old renderer, we're essentially rendering a bunch of spheres, and each one of these 2x2x2 sets of spheres is an instance, and this is a cluster. It's a cluster of spheres. So 2x2x2 set of spheres is a cluster, and each one of these clusters is an instance. If we increase the LOD, so the level of detail, to 1, you're going to see a lot more clusters appear per instance. So now we've gone down to the next level where that big cluster split up into, so each sphere split up into another 2x2x2 set of spheres. So this is a renderer where we bin every single sphere onto a 16 by 16 tile, screen tile. So each 16 by 16 set of pixels that try to get rendered are going to look over a smaller list of spheres that overlap that screen tile, and we just ray trace through those pixels, and we only look at that small list of spheres. So if there's a lot of spheres in a tile area, then we're going to have a lot of spheres to test against. So I'm going to link a video in the description, which was done at this High Performance Graphics 2021 Day 1 talk by Alex Evans, where he talks about this sort of cluster-based LOD system, and it allows you to like occlusion cull at different levels of details. So you try an occlusion cull at LOD1, so if things are blocking in the whole instance, basically, you won't bother rendering any of the instance at all. And then if that one fails to get occlusion culled, you go down to the next level and test every single sphere in there. So it's a way of being able to render tons of spheres pretty quick from one perspective. So this is mainly the issue I'm having with this, is I'll probably want to have do ray tracing from more than one perspective, and that's where the bounding volume hierarchy seems to be good, because you can launch rays from kind of any direction and you'll get kind of like the same performance if you haven't tried to optimize your bounding volume hierarchy from a certain view. Right, so another reason why I want to go back to using the BVH method is that, so I think this this tile-based binning method does produce slightly better performance, but the issue is I can't launch rays from different perspectives. So if I were to do a global illumination of some kind, or I launch rays just from different places in the environment, I can't get that accelerated as well as a BVH would. So if we take a look at where we got to with this one, at least, essentially, so before PBR is less crazy, but now we've got PBR, we're getting lots of reflections and things. So we can have kind of quite small spheres. I'm not sure how this is showing up on the video, because it's probably there's probably lots of compression going on. So let me just, it might be good to switch to day scene, but yeah, you can get them kind of reasonably small. And yeah, I'm not sure how it's going to look if we grid align these spheres. So I was thinking maybe we can kind of offset them from the grid a little bit. Yeah, by having them all very similar sizes and kind of grid aligned, but maybe you can offset them. I think it's going to end up causing some restrictions, which I would like to remove. Yeah, restrictions to how different you can make the art or something like this. Right, so looking at the folder structure of the game, this is our source directory. We currently have like game things and engine things kind of in the same directory level in the project. So I think I want to, even though this is a game without an engine, right, I still think I want to have what's known as an engine folder where I can stick all of the engine level stuff in. So what I'm going to be doing is moving in the core UI, because that's just like a UI library, if you will, but specifically for the game. GPU, which is abstracts over Vulkan, and operating system. So we'll just leave GFX and these game things in this directory, and we'll obviously add new ones like editor and some of the game specific things in the future. Right, so I did all the moving via git, so it would, do all the renamed stuff rather than saying, oh, I deleted a file and added all these new ones. So they're now all living in this engine subdirectory. We've got core, GPU, OS, and UI. So now it's time to patch all the code where all the files reference where the old files were and just point them to the engine subdirectory now. Right, so let's talk about how I want to architect this new graphics renderer from going on. So we talked about having our previous render being this tile-based binning for spheres. And we tried what's known as a bounding volume hierarchy in the past. And I want to go back to doing a new and improved version of that. So let's talk about a bounding volume hierarchy, what it is, and what improvements we're going to be making. So on the left here, you're seeing as if you're looking into the world through a camera. You might have your spheres are inside of a bunch of volumes. So inside here, you might have a couple of little spheres in there, couple little spheres in there, and two little spheres in here. So when you ray trace against this bounded volume hierarchy, you first check this outer one. So imagine you're trying to draw a pixel that represents one of these that is on one of these spheres. You will check against the outer one. It's an axis line bounding box. Do you hit? Yes. Then you check against this child here. Do you hit? Yes. And then you check against this bounding volume hierarchy. Do you hit? Yes, I do. And then you check against this sphere. Do I hit? Yes, I do. So then I, color the pixel based on that sphere. But obviously you're not just checking each of them going down the hierarchy. You've got to check the other boxes as well. And after I've checked the sphere as well, I missed that one. Then I come out, I check this box. Have I hit this box? No. So that means I can't possibly be hitting any of these spheres. So then I pop back out again and I check this box here. Have I hit this box, when I try and do a ray for this pixel? No, I don't hit this box here. So I don't try and render these two spheres at all. So you can imagine when you have a very dense scene, this can give you some big savings, and it can happen from anywhere in the world. So on the right hand side is a tree version of this. So you can choose to have your nodes, you can choose to have 2 children per node, so it's like a binary tree, or you can choose to have more. The first one I did was a binary tree, and it had axis line bounding boxes for the nodes, and it had spheres for the children. Spheres for the leaf nodes. So if we were to draw, so this one represents this outer box, this one here represents this box here, this one here represents this box here, and obviously these two represent these two boxes in there, right? So if we talk about those spheres, they'll be hanging off here as some leaf nodes, or as part of this leaf node, they'll be sort of belonging to this data strip, this node here. There'll be another 2 here and another 2 here. I think in the previous version that I tried, I actually had 4 spheres per leaf node. So this is something one of the improvements that I want to make is I want to have more nodes, more child nodes per node. And the reason is because I think part of the issue is when you're comparing the children and seeing if you hit the children, I think part of the issue is they weren't. I think it was less cache efficient basically. So I want to try this improvement out, and see if I can basically pack the children into like a cache line and hopefully iterate over all of them and check them together, or check them one after the other, so we're not coming back. So hopefully maybe they stay in cache more, or maybe we can go one after the other and not get interrupted by having to fetch more memory. So, and also the other improvement that I want to make is we're currently rendering a bunch of spheres, right? So as you can tell, the bit of the problem with the spheres was that they're all kind of like the same sort of size. Now, I want to try and have this rendering art style use these spheres in a way, but I want to have it be a little bit more flexible. So I'm going to upgrade the spheres to ellipsoids. So we're going to be able to change the radius on the X, Y, and Z dimension. Also, they're going to be able to rotate in local space. So we should just be able to essentially draw models with a bunch of ellipsoids. And that will that'll hopefully allow us to have a little bit more flexibility so the art won't be heavily constrained. So one other benefit of doing ellipsoids as well. So this was a real big problem, I think. Doing these ray verse boxes and then with an if statement saying, hey, if I'm the leaf node, actually do ray verse sphere. And this means that you have two different branches on the GPU, and the GPU if it's running in lockstep with like 32 other threads, and the other 30 other threads, some are on leaf nodes, some are not on leaf nodes. You're going to be doing two different types of intersection tests, which means you basically have to run both the code, like both sides of the branch, because some of the lanes have to execute the axis line bounding box tests, and the other ones have to execute the sphere verse ray tests. So the other improvement that I want to make is rather than these being axis line bounding boxes, they're going to be ellipsoids. So everything is going to be ellipsoids all the way down, and hopefully this means that there's less inactive lanes when inside the if statements when we do the intersection tests, and we're going to be making more optimizations as well. But yeah, that's basically the idea. So let's get started by just cleaning out the old graphics file and just getting the bits in that I feel like we need to keep, and just start by ray tracing a single ellipsoid and just seeing how that looks. Right, so we've just stripped out everything from the GFX module now that we don't need. So we've kept our UI renderer, our debug drawing API for like basic 3D and 2D shapes, and the AMD Fidelity FX parallel sort, which I ported over to my custom shading compiler. So if I press F9, I still get the texture viewer up, and we've removed a lot of resources as well. So just got the essential ones, and we've kept the PBR stuff, obviously, because we've worked on that the past couple of weeks. So now the next step is to basically get the cube map up and running, and then get an ellipsoid rendering. Okay, so now we've got a new shader in, and this is where we're going to render our ellipsoid in. But first I just set up the shader so that it just renders the cube map to the screen, and then that's it. So we'll put the ellipsoid in the middle in just a sec, but we've got this little cube map here that we can look around in. So just a brief look at the code. We're just launching a compute shader full screen, and we've got a pixel on the screen, and we calculate the ray origin. So there's the ray origin in view space, the ray direction in view space that goes through the pixel into the world from the view's perspective. Then we convert that into a world space direction, and here we're going to be doing the rendering of the ellipsoid, and we're saying if we don't hit anything, sample the cube map and then set the final color to that cube map as well, and then flip the y coordinate, because if not it'd be upside down, and then render it, just put the pixel out to the final screen image. Okay, so I've got the ellipsoid in the scene now, and as you can tell, it's animating along a single axis, and it goes pretty flat. And there's a bit of a glitch there where it sort of fizzes out when it reaches complete zero along a single axis. Yeah, we just got to be careful about that. So we're going to be adding the actual ability to like rotate the ellipsoid before we ray trace against it. But that will obviously come later when we're doing the BVH. So it's not just going to be limited to the axis aligned radius. It will actually be able to rotate over quaternion. And right, so we took the ellipsoid intersection code from IQ here on Shader Toy. So it's just this ellipsoid function here. It takes a ray origin in and a ray direction, and then a radius of the ellipsoid in the local space of the ellipsoid object. So if you want to apply any translations to the actual ellipsoid, you actually apply the inverse translation, or sorry, transform, so rotation, scale, and translation, to the actual ray origin and direction instead. So yeah, that's what we'll be doing in the future. But let's take a look at the shader code where we've integrated this. Okay, so here we've added this code here. So we've just got this radius, and on the x coordinate, we're just basically taking the time in seconds and, you know, making it animate from 0 to 10 along the x. Y is 10 and z is 5. And we're using that ray verse ellipsoid function that we saw earlier. And then we're just saying if we've hit, do that shading from the using that PBR code which we made in the previous devlog. So yeah, this is a good first step, and the next step is to actually construct some form of BVH and then get the first root node of the BVH rendering. Thank you so much for watching, guys. So yeah, if you want to catch the VODs, there's a VOD channel on YouTube. There's also a Twitch link if you want to see the schedule in your time zone. And there's a Discord link if you want to come and hang around in the meantime. There's also a source code access for people who subscribe via Ko-Fi or Twitch, and you can run that on your PC on Windows or Linux. So yeah, thank you so much for supporting me, for everyone who's supported me already. Really appreciate it. And I'll see you guys in the next one.